everybody for coming back. We have another IT/OT Convergence panel. Our esteemed group this go around is Bob Lockhart, Vice President Cybersecurity from the Utilities Technology Council, Steve Rawson, Assessment Team Member from the Idaho National Labs, and Brad Williams, Vice President, Industry and Strategy, Oracle Utilities. Christina, we are going in the order in which they're listed? Okay, Mr. Lockhart, you're up. Thank you.
Okay, hopefully that works. Is that okay? Okay, so
Sounds good. Thank you.
Thanks, Chairman Hawk, Commissioners, staff. Thanks very much for asking us to participate. This has been a fantastic event so far. So, where do I point this at to get it to work? No, it's on. There we go. Okay, so just real quickly, since not a lot of people know who UTC is, Utilities Technology Council, we're a membership association of utilities and their technology partners. That's a fancy word for vendors. And we're dedicated to supporting critical infrastructure providers. Most of our members are electricity utilities at the moment. We have obviously some public utilities that are doing water and gas as well. We have one railroad that's a member. But we're basically, as the third bullet says, they're trying to create a favorable business environment, a favorable regulatory environment, and technology environment for our members. So there's a lot of information sharing we're doing, collaboration. We're based in DC, so 2 or 3 of my peers will be on the Hill at any point in time, talking to congressional staffs, talking to FERC or whomever, and a lot of education. So what I wanted to do, and I talked to Christina about this, is start off with just what am I hearing from my membership? How are they thinking about IT/OT convergence? How are we addressing it as an organization? Okay, so this is the culprit right here. It's just one example. So somebody yesterday, my editor yesterday, said, what is this IT/OT convergence thing? I said, well, I shared this picture. I said, okay, so that big round thingy in the middle and the pole and the wires, that's OT. And I said, those little sensors that are clipped onto the wires, that's IT. You can see the little antennas there. So it's just a way to understand it for people. The way we are considering it, though, is not just technology. And this is not my invention at all. This is how our members asked us to look at IT/OT convergence. So we split it into 3 areas, which is what should management at a utility be doing? What is the technology that's involved, and what kind of education needs to happen? So not just the techie stuff, although that's very important. We do talk about that a lot, but there's a whole lot of things get wrapped around what's going on in that picture, and we want to make sure our members are thinking about all that as well. So our approach, I think you said, okay. Our approach is we ask our members a lot of questions. We send out a lot of surveys that are just, 5-minute hit, 10-minute hit, tell me what you think about this, tell me what you think about that. And I know you can look and say, well, surveys are not valid because they're surveys and it's what's with somebody's mood, but we try to ask factual questions. Just, are you doing this or are you not? What do you think? Maybe, what have you been told by your supplier, stuff like that. So a lot of, like you see here, maybe 5, 6 screens, and then we're done and we collect the information. So here's an example. Recall I talked about the 3 areas that we're considering for IT/OT convergence. The first is management practice. So this is what 91 utilities of our member utilities told us they care about as far as management. And you see the huge bar there is changes to organizational structures. That's about 70 utilities saying because of IT/OT, my org chart is changing. Okay. Now what you need to think about is when your org chart changes, people's lives are affected, and that affects decision-making processes, right? Because now you've got not only what's the technology going to be, what's it going to cost, but will I still have a job after this? What do I have to do to protect my own interests? And that's not a bad thing. I mean, people should care about their own futures. But we have to remember that's all rolled into the process as well as, should I do carrier Ethernet or should I do IP/MPLS? There's a whole lot of other stuff going on. You can see the top line there, new governance committees across IT/OT. The members of mine that have been successful in integrating IT and OT have been the ones that took a lot of time to think about how are we going to do this, how are we going to coordinate. I can tell you in a very tall building that's very close from here that you can see out of one of the windows, they had a lot of meetings of the vice presidents of the different divisions to decide, okay, here's all the different functions we're doing that are related to IT/OT. They had this huge matrix, and they made sure that there was only one group responsible for each of the different tasks, and they made sure that every task had someone responsible for it. So they got them all, the demarks, it got rid of all the, this my job, no, it's my job, no, it's, I don't want to do it, I don't want to do it. So it was very much a, how are we going to collaborate? And we're not just going to have good intentions. We're going to put it all on paper. All the VPs sign the document, and everybody marches to that now. And they said it was like going through hell to get it done, but worth it, because now they have a reference point for any decision. So some of the other staff rotations, I was talking to one of my member utilities last week. They've got a sort of a central rotation group that engineers go in and out of it for 6 months at a time, whether they're IT, whether they're OT, and there's a little permanent group. So they're just trying to cross-train people. Changes in leadership, again, I've seen some where IT people have taken OT positions or vice versa, and the ones that have been effective have been the ones who listened. So I've talked to 2 people in the last week who said, well, the first 6 months all I did was listen to people. The first 9 months, all I did was listen to people. These are mostly people coming from operations and to run a big IT shop. So kudos to them that they were smart enough to say, I don't know this stuff and I need to know it, and the only way I'm going to learn it is from the people doing it. So very much management has to engage and decide how and have the willingness to support that this overlap is going to happen. Okay, technology part. Now, I'm a little unhappy with this slide because I can't really share all the data that's in the study that we did. We asked a number of our utilities to tell us for 11 different applications, how do they rate the criticality of the telecoms for that application. Now, I gave you the top one because it's obvious to everybody that teleprotection is going to be at the top of anybody's list. But the others, you can see there's a variance in a lot of them of, yeah, to us that's a high priority. Others say it's low. Some say it's medium. And kind of the point there is this slide, when I first charted it in Excel, that's when I stopped thinking about best practices for utilities pretty much. Because look, you know, those are all utilities that are large and successfully serving their customers, and they have very clearly different views on things. So I sort of have migrated away from best practices to best questions. But my point with showing you this slide is there's a lot of technology issues we're looking at. All the communications technologies you heard about in the last session, I've seen every possible permutation of those among our members, and I can't say that one's better than another other than the power is on, and it's reliable, and they're comfortable with what they're doing. As far as education, what we're trying to do here is level set between IT groups and OT groups. So if you think about the background of someone like me who's IT, I started out as writing software at a desk, a very long time ago. And you think about somebody who maybe has OT, they might have started out at the top of a pole doing splices or something like that. Now you're telling these two groups to work together, and you're not going to just say, well, hey, just go, right? So this slide is just one from a deck that we used at our annual conference last month, and we just said, hey, all you IT guys, come on in this room. We're going to start showing you some of the cool OT technology and what it is and how it works. And again, this was, as you can see from the source, AEP did this presentation. And it was just an engineer from transmission saying, okay, this is what relays look like. You hear about relays all the time. You may be writing software to control relays. This is what they look like. And then there's about 10 slides after this to describe, here's how they work, what they do, why, et cetera. And we had a full house for that presentation because there's a good understanding that people need to know a lot more than they do. So we're trying to level set. The next session after this was explaining IP to operations people. Right, so same thing, right? Okay, yeah, because they're used to TDM, they're used to non-packet networking. So we're just trying to get everybody to a similar level of they can talk about the same things in the same ways. So, and this is my last content slide already. So this was from the same survey that the first slide came from. It's just a question, what do you care about? What are your biggest areas of concern? And I think the flippant response to this one is utilities have a balanced view of everything except they're terrified of cyber. So one way to look at it. I'm a cyber guy by background, and my experience has been that cybersecurity issues are usually ranked a lot more highly than they are funded. So I'm, of course, been trying to change that for 25 years, but it's one of my bosses said cybersecurity is the most important thing that nobody wants to spend any money on. So we'll see. But you can see, again, a lot of those issues are not necessarily technical issues, right? You got configuration management, which is very technical, but you also got governance of systems. Operation and maintenance is technical. Cultural differences we talked about. So you can see utilities are thinking big picture. And again, none of this is my content. This is all my members saying, here's what we're thinking about and here's what we care about. So that's all mine, and I guess whoever's next.
Thank you, Mr. Rawson.
Guess I gotta do the tall guy thing. Here we go. Okay. Hello. There we go. So just real quick about me. I graduated from the Navy's nuclear power program a long time ago. So I've been dancing around OT and IT basically since high school. After college, I did a little programming for a little bit. And then since then, I've been working in OT mostly. I was a SCADA engineer for a public utility in Northern California, maintained the OT systems in the control center, including interfacing with ISO. For almost a year now, I've been with the Idaho National Labs, delegated to the ICS CERT assessment team. What did I do? Oh. She stole it. I thought I lost it. Okay, so real quick, in my opinion, oftentimes the difference between IT and OT comes down to how they prioritize things. In the cyber world, we often use CIA, talking about confidentiality, integrity, and availability. And how we prioritize these things really shows the difference between IT and OT. In IT, we're protecting things like critical information, PCI data, PII data for your customers and your employees, making sure that when you talk to a partner like the ISO, they know it's coming from you and you know it's coming from them. That's our integrity. And of course, we want our email to be there when we want to use it, right? But it's not that critical. If they need to reboot the server, we can do without it for 5 minutes, or 10, or even half an hour. We switch over to OT, right? But the DCS for your power plant can't go down for half an hour when the plant is running. It just doesn't work. So you have to plan those downtimes around when the plant is down, when you're doing a maintenance schedule. With integrity, it's become more important recently because the bad guys are getting better at what they do. In the past, we didn't really care because we had a private network, a completely private network, and we knew that when a breaker command was issued, we knew where it came from. So it's getting more important now that we want to know that it came from our control center and not some guy that spoofed our radio signal. Confidentiality, it's been a non-issue really. On the assessment team, we tell people to protect their information about their systems from the internet. We don't want to see that you're using a Cisco router when we search for your, open source data on your website. But really, there's not much confidentiality on an OT system. So this isn't should we converge, because of course we should. IT and OT should work together. It's more like how should we converge? The IT guys, they've got really good logging and monitoring. We probably don't want to spend money picking that skill up on the OT side. The same with firewalls and networks. These guys know what they do and they do it really well. On the OT side, you've got the SCADA and EMS managers. They know what they're doing. I don't know an IT guy that would touch a PLC if you forced him to because he's scared of it. When you start talking about newer products like smart meters and AMI, it's a good time to converge, right? It's not all one. It's not OT, it's not IT. It's really kind of both. Because we talk about near real-time communications, not instead of real-time. And so that's it there. As we come along and we do converge, we have to, like he talked about with his surveys there, we got to look at the differences between the groups. Where did their education come from? Were they, PEs, or where are they computer science graduates? You know, are they reporting to the CIO or the COO? And the cultures that go with those organizations are very different. Even your mid-level management, you know, you're talking to a plant manager who's more concerned with keeping his plant running, or an IT manager who may be more concerned with how much he's spending on new equipment and how long it's going to last in a refresh cycle. And then what it really comes down to all the time is availability. Do you have to be up and running 24/7 with the redundancy that requires, or can you reboot a server on Patch Wednesday, the day after Patch Tuesday? You know, to me, those are key things that we just need to be aware of when we bring the groups together. So when we go out and we talk to utilities, we talk to all kinds of different utilities, but we see a lot of electric utilities. And we've seen probably every flavor of IT and OT integration. We've seen the IT group, whether just on an empire building mission or from management, come in and try to take over. That doesn't work real well. We've seen the OT group just refuse to work with the IT group. That also doesn't work real well. And we've seen everything in between, quite honestly. Recently talked to a utility that the IT group was moved under the COO, and they were going through those growing pains. It seemed to be working pretty well, but time will tell. So that is the end of my slides. I intentionally left it short so that we could have questions.
Very good. Thank you. Mr. Williams.
Great, thank you. Thanks for having me as well. And just by way of background, I am a power system engineer, spent 20 years on the utility side, transmission and distribution planning and operation. My entire career has been around technology innovation, particularly starting off with integrating large renewables in California, and then distribution automation, substation automation, distribution and outage management initiatives, and quickly came to realize that utilities really needed to get their arms around this whole issue of data and data management as we are evolving and becoming modern power delivery companies, and spent some time at Gartner as a research analyst, really pushing this whole area of IT and OT convergence. And then have been with Oracle now for about 8 years, back on the technology innovation side of things. So one of the things I want to add to this IT and OT conversation is the CT part. That's the customer energy technologies, the edge of the grid. And so I really want to emphasize that connecting the edge of the grid requires IT, OT, and CT, and we've been talking about that, but it is a specific technology that is unique to customers that we also have to consider when we are bringing in the integration of that. And that's what will enable us to actually see some of this vision of the future and modern distribution grid. So let's start with some of the key challenges that we're seeing. And I'll start with the customer, because I'm going to be spending a little bit more time on the customer side of this. Is our customers expect more. They expect more from all of their providers, whether it be their utility, their phone company, anybody who they do business with. They expect more, and they expect better technologies to engage them. And frankly, a lot of it driven around smartphones and social media is part of that expectation. And that requires data from complex interactions with distributed energy resources, which we've talked about all morning, and other smart devices at scale. And so what I mean by that, this is way beyond proof of concepts. This is millions of devices that we have to engage with in real time, near real time, to be able to support this vision of a modern distribution grid. And then we've already also spoken about the platform, and we need an architecture that can support IT, OT, and CT interaction. So one of our customers is quoted in a press release talking about smart technologies coupled with integration of data into new systems and processes are allowing us to provide ever greater reliability and value to our customers. Talking specifically about grid-side value from these smart technologies. Okay, so I want to start with the home, the building. And a lot of this is actually driven outside of any utility influence. It's driven by customers' desire and customer behavior, and to put in things like rooftop PV, or put in a smart thermostat, buy an electric vehicle. These are typically not decisions driven by the utility. It's driven by the customer. So I think it's not too far-fetched where builders will be building subdivisions that are smart homes and to enable to be a microgrid as part of the subdivision. And so one of the things is influencing building standards that would be a more sustainable growth strategy, that buildings would provide a certain amount of their own energy with rooftop PV or batteries, be able to have smart charging for electric vehicles and demand response with their air conditioning. The other attribute about a modern home is very high efficiency standards, are high efficiency, double or triple pane glass, very highly insulated. And then when you couple that with a smart thermostat, that actually creates a energy storage, if you will. It's a thermal energy storage that we can actually take advantage of from the energy delivery side of things, because you can invoke things like demand response on that thermostat or that air conditioning compressor, which is one of the large loads on a home. And with the amount of thermal energy storage within that home, you could be relatively transparent to the customer that the temperature is increasing, because you've got high insulation and the temperature is holding constant as long as the doors aren't open. So that's a resource to be leveraged when we start talking about smart grids and smart energy. And I want to come back to that. When you go and buy a thermostat today, you go to Home Depot, Lowe's, whatever, you see these front and center smart thermostats. And by the way, these are Wi-Fi enabled. And when you connect them, it's very easy setup. They give you all the instructions, and it comes with an app for your phone. So when I set up mine, it was probably a year ago now, I get a message from the supplier saying, do you want to participate? Do you want us to look to see if your utility has any programs that would take advantage of this smart thermostat? And of course I said yes. Turns out my utility didn't, but I think that's very innovative. The fact that I went and bought one, and all they're doing is saying, do you want to participate? And that's all cloud, by the way. That's when I registered my thermostat, that information went up in the cloud, and very wisely, they looked at what are opportunities that the utility might have that can further enable the capabilities of something I already own. So I want to take this the next step. As a power system engineer, I understand the impacts of moving to an inverter-based supply future where we will have fewer and fewer large central power plants providing spinning inertia, which is actually holding the grid together. It's what allows us to have protection and control techniques that we use today, and allows us to do ride-through capability of dips and faults and spikes. And when we have a larger penetration of inverter-based technology being our supplies on the supply side, we still have those large spinning inertia of central air conditioning, of refrigerators, freezers, those types of things. And when there's a dip on the grid, particularly in the distribution area, we'll see these things start to fall apart. It's inherently unstable. However, if we think about this to the next step, is the appliances actually can act as a mitigation measure for this intermittency, for this issue, because if I'm smart enough, I can build a little relay on these compressors to say if my voltage or my frequency drops, I'm going to trip out, and that actually will protect the unit itself to last longer during those, because it's not going to be involved in that disturbance. And if it's only tripped out for a few minutes, which is enough typically for a condition to restore, then it's relatively transparent to the customer, yet provides a more reliable and stable grid. And we're starting to call this in the power systems community synthetic inertia, in the fact that the appliances itself are responding to these grid-side disturbances, and it's actually the most cost-effective way to mitigate some of these issues, as opposed to building wires and infrastructure to try to deal with some of this intermittency. So the point of this is customers are buying these technologies. So regardless of what the utility is doing, I think it's a great opportunity to connect and engage those customers as part of the solution to some of the intermittency that these things bring. When I was connecting large-scale solar and wind projects, we required the developer to provide any mitigation for impacts that they caused. Now, when we get down to the consumer level, it's pretty difficult to identify specific mitigation measures, but here's an easy one, is influence standards that would enable the appliances to respond to some of these types of disturbances. Okay. One of the other aspects is how do we engage those customers? And so this is the important part, is the fact that they have these devices are only as good as the utility is able to engage those customers to use those devices. So this is where that customer engagement model becomes very important, and we can offer programs that will leverage some of the consumer technologies as a grid-side resource. So for example, customer side behavioral demand response. So we've been offering this, our O-Power solutions have been offering this for years, where we influence behavior based on comparing to your neighbor, or this is what the most efficient customers will do, and they find that the behavior science behind it is engaging what it is engaging customers to respond to these events, and then the same thing, engaging customers for grid side events, I think will be even more complicated, but even more important. New solar offerings, new DER programs that can be targeted to meet certain issues on the grid become real important. Okay, so we've talked about this is the customer, and there's a lot of resources that can be tapped in, but the challenge that we've heard in this morning is our ability to model and manage all of these details. We need to have a model that has full visibility of the grid, including the customer, including the distributed energy resources and capabilities that customer may have. And that is IT, OT, and CT interaction. Okay, and when we start talking about data, the big growth, the big data is at the edge of the grid. And this chart just shows as you add more technology, so the big jump here, I can't really show that, but you see the AMI deployment is when it first starts to, these are smart grid initiatives stacked up. AMI deployment is the big one where the data really jumps. Then you get into programmable communicating thermostats, basically smart thermostats. And then all the other beyond the meter technologies that we just talked about is where the big data, the big growth in data is occurring. Gartner just did a recent study on the growth of devices in the home, 83% growth on smart consumer energy technology devices of data that is available year-on-year growth, 83% per year. So part of that is just people buying those thermostats. Smart buildings, 43% growth year-on-year of data. And then even on utilities, we've talked a little bit about some of the sensor data that is beyond the typical reach of SCADA systems, but we can collect that and leverage that for grid optimization. So that's the real challenge, and that gets into the IT side of this, is like how do we capture this and package this such that it can be used to actually drive performance. So we've already talked through some of the communication stuff. Certainly Internet of Things is one of the solutions here. We have a customer that is using their AMI network to control their distribution automation devices, and it's a dedicated communication channel within their AMI network, so it's not necessarily shared with the meters, but it's an IoT type of device as far as how it works. And then when we start talking about the consumer energy technology, in the same way, we are bringing that back through an IP, IoT, Wi-Fi enabled type device, and bringing that back through the field message bus, through standards, and back into the enterprise applications or the OT applications. The one thing I forgot to mention in the middle of that is this home automation hub. That's another quickly growing technology that consumers are buying. Amazon, Apple, Microsoft, Google all have one. They're cool. You talk to it, say, play my favorite music, I want to watch whatever it is on my TV, and it just does it. Well, these home automation hubs can run apps, home energy management apps to optimize the energy in the home. And so in a sense, it could be a distributed process to engage the other connected devices within the home to communicate back to the utility. So that's the other thing to think of. It's not, utilities won't necessarily have to talk to every single device. They can talk to home energy management apps, and the home energy management app will determine what it wants to do based on whatever the consumer's preference is. So that's the other thing, which will help simplify actually some of the communication. And again, these are technologies that people are buying regardless of what utilities are doing. Okay, we've also talked about the platform. And so I don't want to go too much further on this, but the platform is integrating all of these other technologies and making these available to other applications that will do some of these smart things. Because not all of these, these are emerging technologies, so all of these do not exist. But what we want is a platform that can integrate the data and provide smart applications that can run on the platform. Things like outage management can be thought of as an application that runs on the platform. Things like advanced distribution management, volt-var optimization, FLISR, can be an application that runs on the platform. DER management can be an application. And by the way, I show the DER management in this hierarchical format because it could be using distributed processing, like I'm talking to a microgrid or talking to a building energy management device. Certainly analytics, and then ultimately we're talking about transactive energy, and all of those need a complete view of both the customer and the technology. I'm not going to get into this, but I wanted to just show that security can be dealt with on the consumer side as well as the IT and OT. So what I show here in the middle is the separation between the control system and the IT enterprise system. And this is typical of utilities, that they have this separation, DMZ, separated by firewalls. Down in the lower left, you see the consumer energy technologies, and that is brought up through a CT message bus. And by the way, can do the security around that, can do encryption, can do acknowledgement of receipt, and all of those type of requirements that you would expect for cybersecurity standards. The other thing you notice with this architecture is nothing goes directly into the control network. The control network actually pulls the queue after those messages have been validated and determined to be expected and secure, that it's not holding any viruses or bugs or things like that. And then in that polling mechanism from the control network, is those messages are brought back into the control system for optimizing the grid. Okay, I just want to go through two quick examples of IT, OT, and CT convergence. So in this case, we're using grid analytics, an IT application, mining meter data and looking at voltage data in particular. And what we have here is pattern recognition which is indicative of insulation failure of underground cable. Okay, this is an IT application. Now we've integrated this into our OT application, our distribution management system, and it creates an event to say, this is indicative of a cable failure. Here is the event, and you're going to log it in the same process that you would log an outage or another type of fault on the network. It would actually show visually. You'll see that in the red box, and operators will take action because it's part of their core business process. And this is what we call digital transformation, is we are taking information and tying it back into our core business process to drive optimal performance. So this is where we say analytics by itself actually does no good. Yes, it creates cool charts and graphs. It gives us some indicator, but until we actually tie it back into our business process, it does no good. And this is what I'm saying is digital transformation is automating those processes to leverage that information. And now the next step of this would be engage the customers to invoke demand response to offload this condition that's been identified. And that would be the full IT, OT, and CT. One more example, we talked a little bit about electric vehicle adoption. In this case, we can mine that meter data, identify that this customer has just bought a new Tesla, he's plugged it in, and the demand has gone up, and we recognize that, and now we're worried that we don't have the infrastructure to support that. It possibly could blow the transformer and cause disruption to the whole neighborhood. So that triggers an event to say, I need to quickly make sure we have enough capacity to support this electric vehicle, and if we're good, then everything is good. If not, let's look at where do we have available capacity, and we look at the load shapes of the neighborhood, and we say, hey, there's plenty of available capacity. Let's go market a smart electric vehicle charging rate that allows us to use the existing infrastructure to support electric vehicle and perhaps provide some demand response capability of the charging in order to have a win-win, provide them a more cost-effective rate for charging the vehicle and minimizing the impact on the grid. And you can use the same use case for many types of adoptions, including rooftop PV, batteries, what have you. Lots of capabilities with these types of use cases. Okay, one case study, large customer in California that we support has 3 gigawatts of rated rooftop or solar capacity. Currently have 600 megawatts of customers rooftop PV that's connected into their grid, and it's causing problems. It has caused problems in the fact that these are net metered customers in California, and so they have no visibility of what is load versus what is distributed energy. And when we start talking about planning, it makes it very difficult because all they look at, and I used to be a planning engineer, all we look at is what was the previous load, and are we getting close to what are the limits of the network. And in this case, all we see is the net metered amount of load and distributed energy resource. So it makes it very difficult to plan and do things like temperature sensitivity. And so the issue there was incomplete. You didn't have full visibility of what was load and what was DER. And that actually created some unsafe conditions, particularly when we start doing distribution automation, fault isolation, service restoration. We didn't have a good view. So the solution was, let's model all the individual customers, granular customer DER models that would be integrated from their customer system, is where they actually populated that the customer had DER, and we would model it in their distribution management system and provide some proactive forecasting techniques. Again, IT analytics, down to individual climate zones, so integrating weather data from 14 different climate zones and forecasting the load as well as the DER, because we were bringing back things like solar incidents and forecast of cloud cover over the next 24 hours and next 7 days. So we could actually forecast what was the intermittency in any given area, and we could automatically respond to that with DERMS solutions or volt-var optimization and things like that, and thereby providing full visibility. And now they're running FLISR, automated restoration of 400 feeders, and have very good reliability. So that's what I wanted to end with. Thank you.
Thank you very much. John?
Some excellent content from the 3 speakers. So let me, again, just some quick summaries. With Bob, I think it's very important with IT/OT convergence. The education part of this is extremely important. And just as an example, NARUC last year, identified IT/OT convergence as a key topic. And I was involved in doing a webinar for NARUC for all the NARUC members on this subject. So UTC, NARUC, many of the industry organizations have said IT/OT convergence is an area that we need to help educate, the members on the challenges and possible solutions in terms of what to do. So it's a very, very important topic. I think and Bob brought up cyber with OT and IT, and I think one of the things that we need to, and Steve would know this very well at Idaho, is you know, we can have a cyber expert on the IT side, but we really can't take that cyber expert on the IT side and put them on the OT side and think that they truly understand the cyber implication. Yeah, I know but Idaho is the premier, you know, in terms of cyber training and penetration testing of SCADA systems. Idaho is the premier location. But yeah, Bob brought this up, but we really have to look at cyber from the point of view of who has the expertise on the OT side, who has the expertise on the IT side, and it's really two different sets of expertise. Okay, and that's extremely important. We've struggled with the issue of cross-training between IT and OT groups for a long time. And one of the solutions that just shook out with the number of utilities that have tried this is, let's take a few members of the IT side and give them assignments over on the OT side. And let's take some folks on the OT side and give them temporary assignments on the IT side. And you know, over time, the groups of people get to know each other. They establish friendships on each side. They truly, even though there's cultural differences, strong cultural differences, and goal differences, as you said, they tend to appreciate better the differences on each side because they have these temporary assignments on each side. And naturally, you'll see them working together to a greater extent, as opposed to a top-down edict, you will, from the CEO, these two groups will work together. You know, how can it be more bottom-up than top-down? So cross-training and temporary assignments on both sides has really worked out well to converge IT and OT in more of a natural way. I like, you know, Brad introduced something that we really, it's not an industry standard and it's really a new concept, the concept of CT. Because we hear IT/OT, and when Brad was at Gartner, talked about IT/OT a lot at Gartner. But CT is important, and I want to emphasize, you know, 10 years ago, when we first started hearing about smart grid, one of the lessons everybody learned right off the bat was there's a new stakeholder in smart grid that our industry, the electric utilities and all of us, we don't know much about, and that's the end use customer. You know, reading a meter and generating a bill once a month is not customer engagement, right? And the early pioneers of utilities that put smart meters on homes and didn't adequately engage customers to manage those expectations found out really quickly the backlash. So, you know, and that's why in April, you spent the first day on the end-use customer, learning about the end-use customer, customer engagement, customer segmentation. And what that brings up is, and Brad talked about grid-side value, or about customer expectations, is we've spent a lot of time in the industry determining business cases and the value, and what that is, the value to the utility of what we're doing. What we haven't spent a lot of time is, what is the value proposition to the end use customer of what we're doing? It's very different. Customer value, CVP, customer value proposition, the end use customer, not the utility of volt-var control, fault detection, you know, the things we're talking about, but the value proposition to the end use customer. You know, we've seen builders build like zero energy subdivisions, right, where the homes in a subdivision with rooftop solar panels, energy storage, and I know AEP did some of this, was community energy storage, where the green boxes on the lawn didn't have a transformer inside, it had batteries inside. And these were batteries in a subdivision under the green boxes sprinkled around a subdivision, so that the net energy from the subdivision might be zero net energy to the utility. One of the things that's a real challenge for us today is the edge of the grid, as Brad said. We need to get data back from the edge of the grid. We can't optimize what we don't know. And so we need to make sure we get data back, but we also need to model that part of the grid. Our modeling has stopped higher than the edge of the grid. The low voltage network is something we've never put controllers on. It's something we have very little data from. And we're now adding, in areas where we have large amounts of rooftop solar PV, we're adding special power electronic based controllers now on the low voltage network to mitigate the volatility that high penetration of rooftop solar PV creates on the low voltage network. And I want to end with, Brad showed the grid management platform, both to take into account requirements now and looking to the future. So we have one holistic platform. Jeff talked this morning about core and applications, and there was a lot of discussion about should this be in the core, should this be in the application, should it be in both? And I think back, I think a different viewpoint on this would be, what are the functional requirements that are needed in terms of the platform of the future? The functional requirements. Let the different vendors and the integrators determine the design of how to address those functions. But our job should be, what are the functions required by the electric utilities? Whether something's in core, whether it's an app, let's evaluate the different approaches by the vendors and integrators and how they divide up those functions with their designs, okay? So let's, if we think about functions, that's really what we need to do as a first step. And then we can determine the best designs, right, to meet those functions. Okay? Thanks.
Panelists, thank you very much. John, thank you very much for the follow-up. Okay, so let me begin with just a general question. I think there is recognition after this panel and the previous panel of this concept of IT/OT convergence. There's a recognition on behalf of the commission. So, mission accomplished there. So, first question is there a way for a PUC to this is happening within our utilities. Is there a way for a PUC to either continue to catalyze this, or have you seen an example where a PUC has done something that has been detrimental to what appears to be essential convergence in the space?
I can start. So I can share my experience, particularly in the UK, where where there's separation between the supply, the distribution operations, and the metering. And what has been detrimental in those regulatory mandates is the distribution operator has the responsibility to serve and connect those customers and provide reliable and safe service. But they don't get access to the meter data because that's another entity. So it's like, how can we be responsible to provide safe and reliable service, but we don't even know what we're connecting to? So that's an example where I have seen something gone wrong because we don't have the visibility to provide the safe and reliable service. And I think similar types of things like, what the customer has, because if you just look at the surface without looking at the real value, you could argue that this is Big Brother. You're going way too deep into my business. But on the other hand, it's like, okay, what is our mandate? Safe and reliable service, sustainable energy future, all of those things. And it's like, that is the justification to say we actually need to know what you have back there so we can provide that safe and reliable service. So we can make sure we can provide the most cost-effective solutions to your connection.
So when we're talking about data, this has come up a few times. I'm trying to marry a few concepts that we typically deal with here at the Commission. So the first is the concept of data, customer usage data in the retail space, so that retailers in the state can offer different interesting products to the end user, and then also I'll get to that concept later, but can we have a conversation about data needs, and that I think conceptually data needs between probably the core elements or platform provider entity and the application provider, or really the application provider. What are there now, based upon this rubric that we're operating from, are there different data needs or more data needs that we need to explore, based upon your answer there? Because again, we typically deal with it in the context of we need data so we can sell better products, but in this new world, data becomes more essential to the various parties to maintain system reliability. And that was part and parcel with your example of integrating the CT piece as well.
Right. So yes, I would say the customer data, and John was mentioning this too, becomes important now as a grid planner and grid operator. Is I need to have that level of data visible in order to provide that safety and reliability. And if I'm going to plan a grid that does not that takes advantage of the customer resources, I actually need to have a model of what they're doing, and then look at non-wires alternatives to say, instead of, because if I didn't know what the customer had, I would build out wires, I would build out substations. And the problem with that is, if the customer actually has a lot of self-generation and stuff, it's like that becomes stranded asset or unused asset. So that's the other aspect, is the most efficient model of what the distribution operator or distribution grid it requires means you have a good model of what you're connected to.
Yeah, it's interesting. We spend a lot of time talking about distributed resources and compensation and net metering. I don't know that we spend a ton of time talking about the data that's necessary for whether it's the utility or platform provider. But it's an interesting observation that I think we need to continue to develop.
So now I'm upset with Brad because I wanted to be the first person to say stranded asset today, and I'm not. So yeah. So there's like two threads to the discussion, right? Because there's all the customer-driven data. There's also a huge amount that the customer's never going to see. Nobody's ever going to see except the grid operators, right? All the stuff that's going on, like that picture I showed, to optimize, the grids. And the volumes of that are horrendous as well. Utilities don't even know if they want to centralize it or keep it local at substations and only centralize it when they need to. And so there's some questions around, does that have to be protected? It has to be kept, the integrity has to be preserved, obviously. How much does it need to be protected? How involved should you be in specifying the protection of that, as far as it affects the reliability of the grid? And then from the consumer part, I liked the way Brad approached that in terms of start from the use cases and work backwards. And I know you're tired of hearing this, but the generic answer is focus on outcomes and not, prescriptive, do this, it's like my slide about best cases. If you look at how different that chart was, you just come away saying, well, how can you have a best case when there's so much divergence on answers to the exact same question?
Very good. Thank you.
Thanks.
Commissioner Trumbull?
Thanks. I just had a question. I guess I'm looking for just a basic understanding of when this OT-IT convergence started. And it kind of reminds me of gas-electric coordination. It has the same feel to it because they're kind of different industries that are trying to work together for efficiency's sake. And then I guess I'm wondering, how do you know when this convergence, it takes place or has materialized? If anybody could talk about that.
So a good first example is smart metering, right? Because you got the meter, which if something happens to that, you're going to roll a truck and send a metering technologist to go fix it, replace it, whatever. But then if you look at what happens to the data, if something breaks with the dashboard that's based on that data, you're going to call up your data scientists or your C++ programmers for that. So you could say 10, 15 years ago, we were already doing some IT-OT convergence, just in the first smart meter deployments. Every different part of the utility is different. I don't like IT-OT convergence, to be honest with you, because I don't think they're ever fully going to converge. I think you're going to see progressively more overlap. But if you look at some of the devices that are, out there in substations and that, and look at some of the apps running in a data center, you're never going to have the exact same, maintenance platforms, the same people, there's going to be more overlap, but I think that's about where it stops. So I hate to say it depends, or yes and no, but for different parts of what's going on, we're going to see the solutions at different points. If you look at synchrophasers, if we'd had those in 2003, we probably could have avoided the Northeast blackout because we could have seen the phase angles way out of, whack, and that. Now we could see stuff like that. So that was probably in the last, 5 years that's become? 5 to 10. Other stuff we're just starting to see now. So it's one of those finish never is kind of things.
As to kind of what started it, I like to call it the IT-ification of OT, and especially in the control center environment. Almost everything is just IT stuff. It's just servers. It's more about how it's used than how it's different. It's not different. As you get out in the substations, then the devices come much more different. They're talking IP communications now, so it's a little bit more like IT, but really it's a very different world. And I agree with Bob. I don't see it ever completely converging where you call up the help desk and say, hey, I need to have my PLC fixed. I don't think that's going to happen. But in your control center environment, it's more likely to have your more generic network engineers or server engineers helping out your operators. So I don't know if that helps with the answer or not.
Yeah, I'll just add that I think it started, way back in the 80s, but I saw it more prevalent in the 90s as the OT vendors started to adopt some of these IT technologies as part of their applications, where suddenly they needed to do a patch update on a device because they were using some software that was IT type of software. And so, again, regardless of what the utility or the regulators were doing, the vendors were already moving that way. And then in the control room, we saw more desktop type applications or desktop infrastructure to support more modernized SCADA systems that had modern operating systems. And then the need for being able to do more frequent updates because the requirements of the utility were requiring more upgrades or more improvement, more availability, reliability, and then security became an issue. Even though the OT space was separated, it didn't mean that you were not subject to cybersecurity breaches. In fact, a lot of them happen from within, which means all you need is access or be able to spoof a radio that you're something else. So and then cybersecurity came on, and now the need for more frequent updates of software for cybersecurity. So I think it's just something that started, like I say, late 80s, and now has become just a commonplace.
One other big driver, in addition to what Brad just said, was the advent of deregulation. Because all of a sudden now there was much more emphasis on having the data you need and the analytics to analyze that data to make timely decisions, because now you're competing. Before we didn't have the competition. So there's much more emphasis on my analytics are on the IT side, my data's on the OT side. How can I bring the two together? And there was a disconnect in the enterprise. To me, the ideal, one measure would be if every group in the utility has the dashboards that they want laid out the right way, the data from any, the data could be from anywhere in the enterprise, but the data they need presented the right way on the dashboards they've designed, every single group to provide the most value to from their group to the organization, is truly the bringing together of data sources, mapping which of those have value, having an architecture that can extract it, bring it over into the right systems, displayed the right way. End result is each of the groups has the data they need presented in the way they need it so they can provide the most value to the organization. That's truly bringing IT and OT together. Yeah.
Very good. Commissioner Johnson?
Mr. Chairman, one of the things that I think about when talking about this convergence and smart technologies is there a disconnect between the urban and suburban and especially the rural, small towns, rural areas of our country. Is there, I mean, when you think about smart meters and things of this sort, I don't think there's too many smart meters in rural areas.
Yeah, I would say it's more associated to time. I think it is inevitable because the children of the people who are living in those rural homes all have smartphones, all have cool technology, and as they grow and become part of the next generation who will become the next farmers or whatever, is like they want access to these technologies. So I would say it's just a matter of timing for the most part. Yeah, certainly urban areas are driving a lot of this change, but you know, in fact, when I was at Gartner 15 years ago, I would have these conversations, and there's some parts of the United States where they looked at me like I was from outer space because they had said this will never happen here, and now they're dealing with it. It is happening here, so I think it's just a matter of timing. And so from that perspective, I do think it's important to protect those who choose not to participate from having to pay costs that they don't get any value for. So I guess that's the other angle of it is it's not fair to subsidize those that participate on the backs of those who don't. So.
Very good. Commissioner Friedman. Okay, Commissioner Conway.
I just had a quick question. The utilization of data and technology to sort of optimize systems and processes isn't industry specific, but Brad, I think it was your chart that showed the increase of data within the electric utility industry specifically. How does that compare to other industries just generally?
It's similar. You look at healthcare, it's these devices, MRIs, all of these things, same thing, exponential growth of data. Manufacturing is another example. It's like these smart manufacturing devices are full of data that's giving plant operators some very good insight on productivity, maintenance, all these kind of things that we didn't have before. So it's not unique to utilities. And in fact, I would say some of these other industries are actually further ahead than utilities because of their competitive nature, trying to get as much as they can out of it. As opposed to the utility industry.
And so with IT/OT convergence, are there lessons learned industry to industry? I mean, is that incorporated into, I feel like the education has to be changing just from a university perspective with how actual workplace environments are changing. Is that being funneled down at all? This is more of a curiosity question.
That's a great question. I don't
Well, part of the problem is, you can apply because data science is data science in one sense, right? So you can apply a lot of the things you've learned, even in social media environments, right? As far as correlating huge amounts of data that some of it's very unstructured. Utilities have those issues as well, where you're trying to take in all the stuff from your grid, but you're hosting the Super Bowl next Sunday and you know that it's going to snow, and et cetera, et cetera. And then you're pulling in feeds from social media at the same time. So there's all that. One of the hardest things for utilities to do is create a career path for a data scientist that will enable the data scientist to stay there and not say, well, I'm going to go work for Uber or Facebook or whoever. That's a real challenge for the industry right now, is attracting and especially retaining the people that are expert in that. But I think the same disciplines flow across a little differently because, again, control systems are different than enterprise systems.
One thing we found is, one thing we can do is in our industry is, bring in very experienced IT leaders that have experience from other industries that might be further ahead, and bring those in ours so we can benefit from their experience. The other thing, as Brad said, with other industries is, one thing the other industries have experienced too is a lot of this data is on platforms that are old and proprietary, and when you try to bring it all together, it's a challenge. Healthcare has had that where the VA found a vet wants their medical records in one place. and all their medical histories on different platforms that are proprietary that have, so it showed us the importance of standards early on from other industries and why we need to embrace standards as much as we do.
Okay, very good. Dan? Nope, go ahead, please. Yeah, we got time.
I liked your summary, John, or at least the summary I took away from what you said, of what this convergence for IT and OT is, which sounds like being able to collect all the data sort of in one place or in one accessible place and then make it available on a close to real-time basis to make good operating decisions.
Right.
And I didn't really think, Brad, that I thought, Brad, when you started your presentation, that was back in phase one for a short while, and we were back at the edge. And but then I have to say I got interested and engaged in it in a practical way, I think. And however you describe convergence, and however the edge, the information from the edge can be used to assist with efficient operations of the grid overall. As you've heard, we have this communication network kind of overlay or component of the modern grid that we're trying to get our arms around. The question that came to mind as I was listening to you, sorry for that long introduction, is to what extent do we need to be concerned about, or in what respect would you recommend that we consider doing specific things to accommodate convergence from the edge and the capture of the information from the edge to make it available for these more efficient operations? Do we have to be? Do we need to be concerned about it, or is it just going to happen? Or can the utilities or whoever it is that runs the communication layer of this modernization, does it not matter to your point about how they develop this communications layer?
Yeah, so I'll address that with a couple of responses. One is the standards, and we've talked a lot about standards already. I think that is important to embrace standards. We've talked about open ADR, IEEE, is it 2030.5? Those are two that we know are very important with communicating with the customer. What I don't have an answer for is how do we get the appliance manufacturers to also embrace these standards? Because ideally, it's like, okay, when I build a house, I want to think about all of the things I might want to do in the future with that house. Not that I will use that or I will actually build that capability, but I want to think about how could I build that capability. So in that case, so let's just talk about air conditioning compressors. This is a really important area, I believe, that standards on designs of air conditioning compressors, it's by far cheaper to build upfront in the beginning of the manufacturing process to have integration, relays, those types of things. I was involved in a very extensive study about problems with air conditioning in highly and densely populated areas. And by far the cheapest solution is a little $5 relay on that the manufacturer puts in the front, as opposed to trying to retrofit or putting in some wires alternatives to try to mitigate that. So that's the part where if you have any influence on like efficiency standards or design standards of homes, that somehow we include the ability to provide control or at least the ability to protect itself from voltage disturbances and frequency disturbance. So I think there's a lot of value in doing that, even if, and so I've had these conversations with some of the engineers from ASHRAE and others, and so some of the thinking is, can we just have like a control bit within the device, a communicating compressor that said if the customer chooses to participate and maybe they get some incentive, that bit would be set to automatically disconnect itself when the voltage is low or the frequency is low, as opposed to staying on. And by the way, when the voltage drops, the air conditioning tries to restart itself, and it's drawing more current. And actually, this is the inherent unstableness of it. Whereas the mitigation measure would be trip it out and then restart it when things are normal. So if there's a way we can build that into building standards, that will go a long ways.
Just one other, not a follow-up question, but an additional question that was prompted by something else you said about net metering. Would your preference be that with regard to DERS or DERMS, that we have two-way measuring, one measurement device for the load that's being consumed, and another device that measures directly the amount of energy being inputted onto the grid? Would that be one way to get transparency into what's happening back there?
That will help. Yes,
Okay.
that will help. You can do some things to model and predict what is the output, and that's what we're doing in the California net metered areas, is just we're creating a model that is weather predictive. But, and by the way, you can do some things like measure the actual versus predicted, and then you can do some continuous learning to improve those algorithms. But by far the best is just to measure it. And particularly if you're putting in AMI, add another channel for DER.
Okay, very good. To my right, your left, is our chief analyst, Howard Petrikoff. Howard, do you have any questions?
Just one I want to follow it up with. On the convergence with IT and OT, if we're talking about a utility, you have a common management, that can bring them together. But in our areas, we have really adjacent overlaps between municipal systems, rural cooperatives, and investor-owned utilities. Do you have any thoughts on how you bring together the OTs and ITs of different systems that are sharing the same geographic area?
I think I'll just start. I think one would be to extrapolate the model. The model I suggested was within one organization, right? The OT and IT groups, and have some cross-training, temporary assignments. Some OT folks for some period of time over in IT and vice versa. I think you could do the similar model across organizations. Have joint working groups or joint groups with certain deliverables and objectives. And I think the more the folks would try to work together toward a common cause, they'd appreciate each other more. And I think just naturally would tend to work together more closely as time went on.
I think it's difficult in some of these rural areas that municipals share the IT with larger organizations like police and fire, planning, taxes, all these things. And I'm familiar in working with some of those small rural co-ops or municipals where the IT is very separate, or the OT is very separated from the IT because they don't want anything to do with them because they're not responsive, because they're too busy working on the other stuff. So I think it's kind of worse in those areas because there's no interest in engaging them at all. They want to just have their own IT staff. So I think there's some inherent difficulties with some of that, and the other thing is the amount of resources that are available for sharing are smaller to begin with, just because they're smaller entity. So nonetheless, I do think it is important. So I don't have an answer, but it is important.
I agree with Brad. The smaller munis and co-ops often their staffs are so small that they are either already working together or will not work together for issues that he already discussed. As you get to the larger IOUs, you often get much larger staffs that allow for specialization. So it's a balancing act, and the smaller organizations, I think, have a tougher time with it.
Yeah. What I really want to say that I'm not supposed to is join UTC and be part of it. But actually, the part of the issue there is that we're doing a lot of this discussion internally is how, because generally the transmission, the bulk power suppliers to those smaller distribution utilities are a lot better funded, staffed, and that. And we're trying to figure out how we can help the transmission utilities form relationships, working relationships with their customers, because a pure transmission utility might only have 20 or 30 customers, right? And so to pass on the wealth, so to speak, or to share their experiences, because, there's just not the resources a lot of time in a small distribution utility to go out and figure out all that on your own. So how can somebody who's already blazed the trail help you? And that we haven't got the answer to that yet, but we know we need to have one. So.
Very good. Marianne.
Thank you. And I guess this is to sort of, parlay into what we're talking about on the collection of the data. We're talking about big data here, right? And isn't it costly to collect that data and to maintain that data?
Mm-hmm.
And so we're talking about, we should be looking at building that into the cost models for the smart grid.
Mm-hmm.
Would you say that was fair?
Well, the ability to collect and maintain that data is important. Certainly, the value of data. Well, as an engineer, I wanted to not get rid of any data, but practically as an IT provider, it's like, well, does that really make sense? So we need to understand what is the value over its life of data and have storage policies. This is where cloud comes into, I think, looking at cost-effective options of where to store data securely. And I know in some cases, we just dismiss some of these other options for various reasons, as opposed to what is it we're trying to accomplish with it and how can we meet the needs of that data. So I do think that infrastructure, whether it be cloud or whether it be on-premise, is required to be able to bring back more data from the customer and should be part of the cost model.
So, and one of the other things people forget about is IP cameras. Streaming video for security at unmanned substations. That's a huge data flow. It's not just the storages. We don't even know if we've got pipes big enough to bring it back to any kind of central place. So I think it was mentioned in some earlier sessions, and some of our members are looking at how do I know what information I can just store locally at a substation. Substations turning into data centers, right? How do I know what I can just store there and only bring it back if I need it? And how do I know if it's safe and protected out there? But I've seen some of our members are doing network modernization, and they've just said IP cameras aren't even going to participate in it because none of our models will work if we do that. So.
Hey, very good. Panelists, thank you very, very much. We appreciate your presentations and your Q&A.